Hi, my name is Rain Jacob. I wanted to share with you how nanotechnology, specifically with nanocarriers and nanoparticles, are being used in Dr. Julian Nguyen's lab at the Eshelman School of Pharmacy here at UNC. In learning more about the research and environment that Dr. Nguyen fosters throughout her lab, I was impressed by the extensive research on developing genetically encoded and genetically engineered biotherapeutics. From Dr. Nguyen herself, I've chosen to review her publication on fast-degrading polyesters as siRNA nanocarriers for pulmonary gene therapy. I was intrigued in not only in this publication, but many other of her publications that utilize nanotechnology to make advancements in medicine. I want to touch more about nanotechnology and in particular the use of nanocarriers in the treatment of pulmonary diseases. So what is nanotechnology? Nanotechnology refers to the construction and engineering of functional systems at the atomic level. So just really how small is nano? Based on the International System of Units, nano means 1 billionth of a meter. For reference, as seen on the picture on the right, 1 nano is about 100,000 times smaller than the width of a human hair. The application of nanotechnology can be seen in therapy and diagnostics while used rarely, yet it is a promising outlook for future use in the field of medicine, as well in the fields of biomed, electronics, healthcare in general, and also in biofuel production. In the Nguyen lab, the research includes looking at nanoparticles as drug carriers for the delivery of unstable and insoluble drugs to target issues. Um, Existing drug delivery systems now are rather insufficient and released non-specifically in the body, which may lead to toxic side effects for individuals. So what are nanocarriers? In order for nanoparticles to function for a drug delivery system, the drug has to be attached to the nanoparticle first. There are several ways of achieving this one being encapsulating the drugs in the nanoparticles. Nanocarriers work by placing the drug within a vector and being able to control release it when bound to any target, thus increasing the local drug concentration absorbed. Furthermore, nanocarriers can be linked to specific ligands so that their specificity to target tissues can also be enhanced. There are many different types of nanocarriers, but in Dr. Nguyen's publication, she explores how certain polymetric nanoparticles for constructing an siRNA nanocarrier that can be quickly biodegradable, which can reduce any harmful side effects to patients dealing with pulmonary issues. Nanocarriers overall are a form of targeted delivery method that ensures that drugs are delivered to the site of interest while also minimizing the damage to surrounding tissues. I really wanted to highlight how the use of nanotechnology and nanocarriers can be used in the future in medicine, offering controlled and targeted drug delivery, including controlled absorption and reduced dosage frequency. Here on either side, you can see the graphs used in her most recent publication and how she uses computers to be able to encapsulate the drugs in lysosomes as another form of nanocarrier. And then on the right is another picture of just how the drugs are able to treat diseased tissues and cells. So overall, this is how nanotechnology and nanocarriers are being used to make advancements here at UNC. Thank you.